So today I'm going to be talking about advanced EDA patterns at the LEGO Group. This is following on from Sheen's talk earlier, although not a prerequisite to the talk. You've already had a bit of an intro to me, but yes, I'm an engineer at the LEGO Group, and I'm also an AWS community builder in the serverless space. And my interest in serverless really did start when I joined tech consultancy and worked with a different range of clients and kind of found a love for serverless, mainly for how quickly you can build as a developer. It's really awesome tech. And yeah, feel free to follow me on Twitter. I took the handle Serverless Sarah, so it's an easy one to remember. So Sheen took us on a journey from where the LEGO Group started to where we are today. I joined the LEGO Group less than a year ago, so I've very much been in the most recent parts of it, where a lot of it is serverless. And so I'm going to be talking about the here and now and talking about the patterns that we use and going quite in depth with those, although trying to make them quite understandable to everyone here. So just to talk through the topics, I'll talk about the squad setups and how it's important as to how we actually code at the LEGO Group, and then diving into what we're all here for, the actual use cases, so going through the architectures, a few live examples in the console, and then we'll wrap up with some benefits, but I feel like we've all kind of heard that because we're now at 3 o'clock, so I think we all know the benefits of event-driven architectures by now. So when we think about the LEGO Group, I think a lot of people think about the bricks. A lot of our revenue comes from the website. And the website, there's a lot more to it than often people may think. And we split it all up into squads who own different sections of the website. So, for example, a team will own the product sections. We might have a team owning the cart, VIP, so many different squads. And I think that Sheen said that we have over 25 squads now at LEGO, so we really are following kind of the model of splitting teams up and having their own domains. So talking about that a bit more, there was a quote by Jeff Bezos that maybe a lot of people here have seen before, that we try to create teams that are no larger than can be fed by 2 pizzas. Now, I know that 2 pizzas wouldn't feed my team because I'm taking a whole one for myself, but the principle is that the teams are fairly small and, you know, between 5 and 10 people, so definitely more of a snack. But the reason for this is something called the Ringelmann effect. And it's the tendency for individual members of a group to basically become increasingly less productive as the size of the group increases. So there's many different reasons for this. I guess a key one is communication. It's much easier to communicate and get along well with fewer members of the team. There's also more negative reasons, such as you can hide away in the shadows once you have larger teams and get away with doing less work. But the principle is there's many different reasons why it may or may not happen. But yeah, so that's why we tend to follow this model. And I know a lot of places like Netflix, Spotify also follow this kind of model. So it's the way things are going. But technically, how do we decouple the squads? So here's a few examples of a few of the squads that we may have. And what I kind of say is it's kind of a workaround effect that decoupled squads equals decoupled code. And I'll talk about how we achieve that before we get into the examples. But essentially, at the heart of it all, it is events that, you know, talk between. And I think we've heard it all before today, so I won't go too much into how events are fired and things like that. But that's how it's all working. And the LEGO Group is a big organization. It really is a journey. It's never perfect. And we've gone from a place of not being event-driven to getting to a place where we are fairly event-driven. But it's a journey, and I'm lucky because a lot of the places that I work on really are event-driven, and we are following amazing principles, a lot of them implemented and designed by Sheen here himself, as he's been at the LEGO Group for a much longer time than me. So one of the ways that we actually technically break these things up is to have separate cloud accounts per team. So when I joined my team, we requested a cloud account from the IT department, and they essentially own the root account, and we use AWS organizations, which I'm sure a lot of you may have heard of, to have a root account and then request a cloud account from the root account. And by using this, the root account can implement certain policies to make sure that we have a standard across the Lego group. For example, we all have to use guard duty, certain things like that we implement. So that's one way that we split things up, and there's benefits to this as well, such as being able to track costs of individual teams. So it's much harder when everyone's on one account to track the costs, where you can look at one account and see, oh, that team spends a lot of money. Do we want to kind of change that or not? And also, it's following the principle of least privilege in that I can only really be messing around with my cloud account. I can't be messing around in someone else's cloud account that I know nothing about. So yeah, there's lots of benefits to that. And following on from that, we also follow a multi-repo approach, which goes hand in hand. So it allows for the separation of concerns. So again, having the payments squad working in the payments repo, in the payments cloud account, just allows us to kind of decouple everything. Again, the well-defined access control, and it allows for team autonomy. So some of our teams, they do work with different programming languages, whether it's down to the fact that for that team it works for them or different skill sets, and it allows that team to really choose the kind of coding principles that they want to implement in their repo. And it also allows for independent library versioning, which may or may not be a benefit. Depends on your approach. And following on from that, the team owns the CI/CD pipeline, which allows for less waiting around. So when I've worked in huge monoliths, everyone's CI/CD checks are in that monolith, and you'll be waiting a long, long time, and then someone's check will fail because someone pushed an error into their part of the code. And it's incredibly annoying because it has nothing to do with your PR. So having them all separate, it really does lead to less frustration and more likely that the test will pass first time. And starting to finish up on this topic before we go into the in-depth examples, this is how we do some of our deployments at Lego in the back end. So we have all of our services listed down the side here, and you've got a good overview of the different commits that will have been pushed into our QA environment, acceptance, and then production. And you can see here that, for example, this commit was not deployed into production, but we kind of look at this, and because the most recent commit was, everything before that has gone into prod. And it's a nice way out of hours if our ops team needs to get involved and kind of diagnose issues. It's all very visual in a UI. But there's many different ways of doing this, I suppose, at different organizations. And the final thing on this topic is the team owns the monitoring and analytics. So we use a tool called New Relic, but other ones, Lumigo, Datadog, do the same thing. And essentially, because the team can own this, I have alarms set up to alert our teams. Whereas if it was all going into one big chamber with 150 engineers, I'm never going to take responsibility for that error. So having the team really owning it, again, it's that thing of hiding away in the shadows when there's too many people, too many chefs in the kitchen, I suppose. Okay, so moving on to the examples. Firstly, I want to talk about event streaming. So the first use case that I want to talk about is customer emails. So we have a customer who navigates the website. They've consented to marketing when they accepted the cookies. And then all of that data goes through into our backend called the campaign service. And the data is processed, a bit of logic to kind of figure out what has kind of happened on this customer's journey. And then that backend then sends some data to third-party marketing provider who then sends an email. So that email may be customized because that person's been looking at cars or they're interested in children's toys, that sort of thing. And another use case for this event streaming is obviously analytics. So all of this data is being fed into our observability platform in order to produce these graphs. So how do we implement this? Well, we have one service to power them all. So in our service, what you can see here is our architecture diagram, which is where we're going to start going a bit deeper. So we have the user who is clicking around in lego.com, and that data is coming into our backend service. We use Kinesis data fire hose. So I'm sure many of you are aware of Kinesis, but the data fire hose we use in particular because of its ability to batch data and to send data into an S3 bucket. And from here, the event object creation sends an event to trigger the Lambda function, and then this Lambda function will triage the data. So depending on the event source or different parameters that we decide to decide upon, we'll then send the events out to different microservices, so essentially different teams. And what it means is that we can just use this one service for all teams, and we can always plug in these different services in order to be able to take the data. And we just add the rules into the triage Lambda in order to define that. And just to show here, what we have is the campaign service that we discussed, which would be the marketing emails, and the analytics, which would be the New Relic graphs. And there's also different ones as well, but I don't want to go into everything. So just to take a look at that a bit deeper, we have the events that come in from the front end. And you can see, I mean, these will look different depending on where they came from. But essentially, you can see the event type, which is a page event. The person was on the URL Hogwarts Castle, and that's now coming into Kinesis Firehose. And this is happening at huge scale. You can imagine how many users we have on the website, and then therefore how many clicks and how much. But Kinesis Firehose can really handle all of this, and it's really designed to work at this kind of scale. So then the Kinesis Firehose batches this data up and puts it into S3. And how it batches is depending on this buffer size and buffer interval, and it's whichever condition is met first. So if the buffer size is 1 megabyte and the buffer interval is 60 seconds, you can see here in these objects, and if I come over here, that we never met 1 megabyte, but we did then meet the 1 minute. So they've been coming in every minute. But on a day like Black Friday, we will be hitting the 1 megabyte and we won't be reaching the 60 seconds. So that's kind of how it works, that trade-off for the batching. And just to add to this, we add things like S3 lifecycle policies to our buckets. We don't treat this as a data warehouse, so we expire the objects after 5 days. And the only reason why maybe not after 1 day is just in case of any downtime, we may want to replay this sort of thing. But we just don't want to be keeping data around for the sake of it. It's a lot of data as well, even though it is only kind of text objects. But it's just nice things that AWS gives us that just happens automatically without us thinking. And if we take a look at a piece of code, I'll be going into this a bit more when I show you the YAML files, but you can see how we have the triager Lambda, we have various setup, and then in the events, it's triggered by S3, we get the bucket, and it's on object created. And then you can set certain rules for where it is in the bucket, and so on. So that's how it works, and I'm sure many of you are familiar with that style of code. The events can be HTTP or other kind of events. After all, it is an event-driven day, so I thought I'd point that out. So if we take a look at a quick example, I'd just like to show you how I implemented this. So my framework of choice is Serverless framework, but obviously this can be transferred into CDK or a different one of your choosing. And if we skip back past the kind of roles and things like that, I just want to show you how I've set up the Kinesis Firehose. So you can see here I've got the delivery stream, and then we have an extended S3 destination configuration. So this is how we're setting up that connection. And you can see how it's so simple in a way. Like, it's only a few lines of code just to be able to get data to go from Kinesis to S3, which is pretty insane. So you can see here that, we've defined the IAM roles, and you can see again we've defined the buffering hints and the prefix. And then just quickly, we do have the triage Lambda function, which I've added the S3 trigger to. And then just because I wanted to show, I'm going to show all of this in the console in a moment, I wanted to show how the triager sends off to different services. Just to make it a bit simpler, I've created 3 Lambda functions, and I want to show that in those Lambda functions, I've put a console log for the different events. So we can, what I want you to see in the CloudWatch logs is that only energy events went to the energy service, even though it's a Lambda. And same for healthcare and technology. And we don't need to go through the code in the triager. Essentially, it's just invoking the different Lambda functions based on the various things that's happening. And whilst I've simplified this a bit here, this is exactly what happens on lego.com for all our clickstream data. And it scales beautifully. So if we go to the console, I'm going to quickly demo this one. So we've got our Kinesis data fire hose. And the nice thing about data fire hose is that it allows us to just test with demo data, so making my life a lot easier. So I'll start sending the demo data. So I think this is sending it out something like, I don't know, one per second. And I'm kind of rambling on here because of our 60-second buffer interval, that the object is only going to arrive in S3 in a minute. So if we take a look at the S3 bucket, in the properties, in the management, you can see that, yes, I've added the lifecycle rules. So yeah, I've added the 2 days. I'm just gap filling here until it comes in. And then in the properties, you can see that we have the event notification. So you can see how it's connected to the Lambda triager as well. And I'm sure many of you are familiar. I've deployed all of this before, saving ourselves the time, because that would be incredibly stressful to have to do that up here. So yeah, let's go into here. So you can see we've got our prefix, e-commerce basically, and then events, and then things it automatically goes in date order. So we have 2022, we're in September, it is the 1st, and we're on this 14th hour because I think it's UTC time. And yay, we have one. So I'm gonna stop sending this demo data to not rack up my AWS bill, even though I'm sure it's pennies. And let's just take a quick look in here. I just wanted to show you what has actually come through. So you can see how it's batched basically in this text file. And yeah, this is just the demo data, of course. This isn't what the Lego data looks like. So then the final part of this is to go into CloudWatch and check these different Lambdas to see, well, did it actually send them off to the correct services? So in energy, you can see that it was triggered just a minute ago. And we have our array. You can see only one energy event happened. But if we go back to, say, healthcare, yes, none came through for healthcare. What was in here? Technology. We had a lot of technology events. We'll go for that. So yeah, you can see that the array came through. So that's kind of the end of the demo for the streaming part of the data. And if we head back to the presentation, now just a quick run through about what would happen in the campaign service to send the email. Essentially what you can see here is we have the data feeder that we've just discussed, and we go all the way, and we've triggered the campaigns API. And then everything beyond that is then event-driven as well. So for this particular service, we put these events onto EventBridge because we'll have multiple logic services branching off of that EventBridge. So things like we might look for, has a user abandoned their cart? They've added products into a cart, and then 2 hours later, we want to send them an email to say, like, did you forget the things that are in your cart? And then once we've defined that logic, we're then sending the event back onto the event bus to trigger the third-party marketing provider to send off the email. And the reason for EventBridge really is to have these multiple things coming off of EventBridge. I didn't want to put it all in the diagram, but there are multiple services defining different logic for different emails. And then the final one was that second use case coming back to it, that all that clickstream data, we can then look at it and provide these stats to the business. So at this moment in time, people were interested in the Airbus rescue helicopter and all this kind of information that provides what the business really cares about, I suppose. So moving on, it wouldn't be an EDA day without mentioning EventBridge. And the example that I want to take here is the payment service. And it's one of our most important services because it's how we make revenue. And in a minute, we have to take 1,000 orders, 200,000 API requests, and we have 150 concurrent Lambda executions. So it's a service that really has to scale, and we heavily rely on it. We really don't want it to go down. And a quick overview of the architecture, very high level, just to show you how it works. On the bottom here, we have Lego business units, and in one of these, it might be lego.com, where someone might want to, probably the usual way that most of us would buy an item, so through the website. But a lot of people also will call up customer services to make a purchase through there. So there's different ways that people can purchase items on not just the website, but all of these have to integrate with our payments backend. And then the payments backend integrates with different PSPs. So like PayPal, those kind of providers that obviously we don't do ourselves. So a few years ago, there was kind of a problem, something that we wanted to improve. And the way that payments worked on the website was that from lego.com, user would make a purchase, it would send a payments request to the payment service, that would send a payment request to PayPal or a different payment provider, and then a synchronous response would come back to say, okay, request accepted, but it's not saying whether the payment has been accepted or declined, it's just saying we've received your request. And then essentially we're waiting around for an asynchronous response from the PSP to say, okay, the payment was declined or it was accepted and it's gone through. Meanwhile, the user is waiting on a loading screen for this payment. And the problem that we faced is that the Lego.com is polling for a status update from the back end. And this isn't ideal because I guess the example that I like to give is that imagine on the 5th second it's polled and then it's got, it says, no, it's not been accepted. And on the 10th second it gets accepted. But in reality, the async response came back on the 6th second, so the customer's waiting around for another 4 seconds. So yeah, the problem here is multiple network requests, more requests for the payment service to handle as well, and it's just inefficient and not as good for the user. So of course, the solution was event-driven. It would be to push the status update from the payment service to lego.com. And so if we have a look at that, what that looks like, on a very simple level, the payments provider is essentially putting an event into our service, which goes onto the EventBridge, that asynchronous response, to be clear, not the synchronous one at the beginning. And then the payments EventBridge is pushing the update to the client EventBridge, which is lego.com. And this all works really wonderfully because the front end, or that particular part of the website over here and the client service is all hosted on AWS. But the question then becomes, when I talked about that second example of the customer services, what if the client requires us to push to a HTTP endpoint? So for various reasons, our customer services has a HTTP endpoint rather than an EventBridge to push onto. And that's a problem because that's not the way that EventBridge typically works. But AWS did come out with something called API destinations where we can send events directly to HTTP endpoints. So you can see here the same diagram, but we've put the client service in as the customer services API. And here we have the API destination, and I'm going to show us how we configure that in the code. But first, a quick thing on how it works. The only way that it's different to EventBridge, which I'm hoping that people have heard about before I dive in too much with it, everything's essentially the same. We have an event, and then we can filter out with some rules. But the difference is the event transformation. So a HTTP endpoint most likely isn't just going to want to accept a classic EventBridge event. So we need to do a bit of transformation. And And if I show that here, firstly, we have the filtering. You can see the EventBridge rule on the left-hand side, which many of you will be familiar with standard EventBridge. But then the event transformation, you can see here that if the client wants it in this sort of format here, and that's the original event, then we're going to do some transformation, and that's simply how it works. It's quite self-explanatory that it's just accessing the JSON object. So a quick demo on this one. So with API destinations, how I set this up is to create a REST endpoint simply for the demo. So not the classic way that we would be accessing this, but essentially I put a Lambda function behind an API gateway to be triggered by HTTP. And that's about it for that one. I just put a console log in here. I just wanted to create a HTTP endpoint for us to hit. And so if we close that up, in the payments service, I have created the EventBridge part. So here we have the event bus, which many of you may be used to. So just setting up a standard custom EventBridge. But then for the API destination, we need to set up a connection. So in here, I've chosen that the authorization type would be API key, but it also handles OAuth and various other authorization types. But I've gone with the quick and easy way. And then we set up the HTTP endpoint, which is the API destination itself. And we have to add the connection. And then we have to add the invocation endpoint, which you can see I've been lazy and not put it behind a domain, but that was just what I deployed. So there's essentially the Lambda endpoint. It's going to hit the API gateway. And then lastly, the EventBridge rule. So I only want events that have the domain Lego payments to be going to our endpoint. And then there's all the other stuff like IAM roles, but I think we'll skip out on that one for today. It's not the most interesting topic, in my opinion. Okay, so let's get rid of what we had before. Let's go to Amazon EventBridge. Firstly, let's take a look at the rule that was created. Wi-Fi's being a bit slow, so let's see. Take a sip of water while this is happening. Thinking, am I in the right region? But anyways, I think that it is here. It's just been a bit slow. Well, let's see if we can send events. Here we go, okay. Oh no. Oh dear. Of course it was going to go wrong when I decided to do things live. I don't know. Maybe I'll just talk through it and see if it comes up. So here we go. So we have the custom event bus. I'm going to say that the event source, let's put it in as EDA day so we can identify it. And let's put the detail type as EDA day because I'm not inventive. And then let's go to grab an event that I already have in the README. Oh, and to be clear, I have made all of this public, so no need to be taking notes. You can copy all of this code. I'll put a QR code up at the end. Cool. So then let's change this to EDA day so we can identify it. Right, so we've sent the event onto the custom event bus that I set up. And then let's go to CloudWatch, and what I'm hoping is that this Lambda has consoled out our event. So let's go to it. We have the REST endpoint, and you can see here, yes, at 3:49, an event came in. And so it's got a load of different information, but essentially we have the body at the bottom. And the way that I can prove this came through with API destinations and not just the standard EventBridge is this user agent says API destinations. So the setup is really quite simple, but really effective. And I think this is really useful, especially in bigger organizations where everything can't be perfect. We can't just have EventBridge to EventBridge all the time. We do need to integrate with HTTP endpoints as well. So that's the end of that demo. And let's go back to the presentation. So next, orchestration. So I know Sheen touched on this earlier, but we have we use a lot of step functions at the Lego group. We're going to go a bit deeper with this about how we go across from service to service with step functions, because the general rule is that people tend to use one step function per service, or multiple step functions per service, but not talking cross service. And the example I want to use for this is the loyalty platform. So this is a reward center where very keen Lego goers will accrue points and essentially be able to spend vouchers and things like that. And this is owned by a whole team of engineers. And it relies a lot on orchestration. And what we mean by orchestration is essentially long-running tasks, so not something that's synchronous. And essentially, just kind of to put it simply in here, it's a flow diagram. So it's saying, okay, we want to run this Lambda function, and if this is yes, then run this other function, and if this is no, then do this thing. So I think we all get the gist of what a step function is, but that's kind of how it's working. And the nice thing about step functions is that you can have waits up to a year with no additional cost. You're only paying for the different processes that run. And you can also have human elements. So you can have things like, if the HR department needs to check a tick box in order to allow the next part to flow, that's also something you can do with step functions, which is really cool. And it's just always really nice to kind of make all these Lambda functions and things and then piece them all together with a step function. And yeah, I don't know, there's just something quite satisfying about it. So the first use case is a slightly more simple one before we go into the demo. A customer, maybe in a Lego store, places an order and they may want to redeem a voucher, and at that point we have to remove the points from their account. But the payment may get declined or something like that, and the reason why we remove the rewards before the payment goes through is because we don't want someone else spending those rewards at the same time. And so we need to kind of come up with a mechanism for this to essentially remove the rewards, then take the payment, and if it's successful, keep the rewards, but if it's not successful, we need to reimburse the voucher to give it back to the customer. And we do this with step functions. So in the service, we have various things going on that triggers a step function. And the main thing here is that we do a wait. And as I've said, there's no additional cost to this wait. So we allow 2 hours for to basically make a decision as to whether it's been accepted or not. And then we'll perform the session cleanup if the payment was declined or something like that. Just it was unsuccessful. And so the cool thing here is that it's all event-driven, of course, and you can see here that in the session cleanup, we're actually triggering EventBridge from the step function in order to basically tidy up the third-party rewards manager. So we want to reconcile the data across all the systems to make sure that what's shown to the customer is the correct amount of rewards. So the more interesting part of this is what happens when we want to do cross-service orchestration. So in a step function, a traditional thing that you may do is in one of the, say, the Lambda functions, let's say that's the process, we might make a synchronous API call out to a different service and then come back. And that's not too much of a problem, like that's a quick call to make. But the problem becomes when you may want to reach out to another service that has a long-running process, such as another step function or something else generally that might be event-driven. And so the way that we handle this is with a task token. So this may be a new concept to many. It was fairly new to me as well, but it's pretty cool. So from one of the step functions, you can essentially in between here, you'll put an event onto an EventBridge. It's not in the diagram with a task token, so basically an ID, and then that will then trigger the other service. So it's all still quite decoupled because you've got the EventBridge in between, and that will trigger, let's say, the step function. And then the end of the step function will put an event back onto the EventBridge in order to trigger the other service with the task token, and then the step function knows to continue. And so final demo of the day before we start to wrap up. So this is the more tricky one, actually. I hadn't worked with this before. So if we take a look, I've got 2 step functions to try and replicate these 2 longer running processes. So let's have a look at order processing to begin with. And just to add a bit of context to this, because you may be wondering, well, why even do this at all? So in our system, we have very much like a distributed different sections in the loyalty platform, and we just have one set piece that integrates with a third-party service. And we don't want all of the different domains to be integrating with this third party, because if one day we want to switch out the third party for someone else, we only want to change the code in that one service. But for this order processing, we actually need we need to reconcile the data in this third party. So it does need to have a bit of interaction from this step function to the other one. So if we look at the order processing, I'm using the plugin Serverless step functions, which is really helpful. And we have a look at the state machine that I've created. So the key parts here is that we have, we want to, in the first part of the step function, and this is all very simple in terms of, the real system has lots of different steps to the step function. But we put a event onto EventBridge, and we have this thing called wait for task token, and that's kind of the additional part here with the task token. And then you can see here that we've just built up an event to put onto EventBridge. And so then once that has gone off, it's going to just wait. It's going to wait until the task token comes back. So at this point, we've triggered this other service, and this has the other step function. And what I've just put here is that it essentially updates a DynamoDB table, which I'm calling the third-party service, but I really didn't want to integrate with third-party service for this. It's just updating Dynamo, setting some points, and then it's sending the task token back onto the EventBridge once that's all completed. With various different parameters, but the key thing here is the task token. And then that will then come back, and essentially it will allow the step function to continue. And the missing part here is that we do have to have a Lambda function to accept that event from EventBridge. So you can see here I have this task token response handler, which is triggered by the event that came back. And in here, you can see I have the send task to success command, which is part of the AWS SDK, and that's what's allowing the step function to continue. We were having some interesting discussions about this last night. We were kind of suggesting to EventBridge that, it would be nice if it just directly integrated with the step function. But yeah, maybe that'll come in the future. But right now, we have to have this Lambda function. So then from there on, I've just added in another step to kind of update another table just to make it a bit more interesting. But what we're all here to see, I guess, hopefully the console responds, is the step functions. So here we have the order processing step function. This is all going to go quite quickly, so try to bear in mind everything that I've just said. And if I just grab an example event here. Cool. So there's the information that I'm putting into this order processing step function. I'm going to talk quickly. You can see here, it is sending the event off to EventBridge, and it's waiting. And let's hope that in a moment it comes back, it's updated the table, and it's finished. So meanwhile, in that time, when it went off, you can see we have this other step function, and you can see, at 4 o'clock, we had, it went through, so it updated the table and then it sent the task token back. And I mean, all the information is down here. Step functions is just really cool. It's kind of easy to debug because it gives you so much information about what happened at each stage. But various things happened. I mean, I can show you that in the order processing table, it did update because I sent the same one as before, but yeah. And it looks like it didn't update it. It's because I sent the same event that I sent just before when I tested that it was all deployed correctly. But yeah, it updated. So that's how these task tokens work, essentially. And again, all this code example will be uploaded online. And then back to the presentation, we're about to wrap up. So just to kind of show you where you can go with this, you can really have many different arms to this, and you can kind of make it quite complicated, but you're doing quite powerful things. It doesn't have to be step functions in EventBridge. It can be SQS as well and other kind of messaging services. And you can do it on multiple different arms and make it super complex. So we're at the end of the heavy kind of part of the talk. I guess to wrap up, I just wanted to talk about a few benefits of event-driven architectures, which I'm sure we all know. But a key one for us at the LEGO Group is scalability. So serverless, all these services that we've talked about, and event-driven architectures, they really do go hand in hand. And because events are handled asynchronously, they can really work at their own rate. So on days like Black Friday, we really don't have to worry about things. As long as it's not a customer-facing call, then these things can happen at their own rate. And with all of these services, we don't have to worry about so much about Black Friday. And in terms of a code perspective, we can scale in terms of just plugging systems in rather than trying to really mesh them all together. And then we have resilience and fault tolerance. Of course, in case of downtime, and we've had this recently where we've not lost data because even though we've had downtime, we've replayed all of our events later on because we've been using queues and things like that. And again, we've heard it all before. If one service fails, the other services are unaffected. So in that sense, it's really cool. Unless the payments platform goes down, then we're not too happy. But then faster development. A key thing here for me, and one that often people miss out, is hiring becomes a lot easier because you're not trying to hire for a skill set that is across the whole of the LEGO Group. You're just hiring for the skills that you need in your team. So I like to use serverless framework. I haven't used CDK too much, but we don't need people who have every single thing like some of those job descriptions ask for, where they want like 10 developers in one. We're asking for a much more reasonable skill set. And developers really don't need to overthink the system. You don't need to be thinking about what if I make this change, is it going to break it somewhere else? They don't need to overthink it too much. And it's just quick to spin up new services. So yeah, that's me wrapping up. If you want to take the code examples, you'll find them on my GitHub. Yeah, everything can be taken, it's all public. And I just want to say special thanks to Sheen Brizzles, who is here proudly watching me at the front. He's helped me a lot with this presentation in terms of I am an engineer and I do very much sit in my own squad. So I don't necessarily find out about all the different domain knowledge because we are event-driven. So he's helped me to kind of reach out to the relevant team members to look through, all the documentation and be able to pull these code examples together. So yeah, I really appreciate everyone coming to watch my talk. It's really nice. So thank you.